Okay, so I'm hoping that you worked on those 4 problems before you found this answer key video, shall I say. Now, I'm going to work one problem at a time because they take up a lot of room on my board. If you're like, well, I understood problem 1, I don't need to see it. Great. Fast forward to problem 2 or 3 or 4, whichever one you actually need to see the answer key for. Because remember, it's a video, so you can even play me a double time if you want. Good? Okay, let's look at this first one. So remember what I mentioned in the lecture video. I am dealing with an equation that's dealing with fractions. Regardless of the denominators of the fractions, whether they're polynomials or not polynomials, the key is get the common denominator, bottom line. So I'm always looking for the lowest common denominator. Remember the technique I showed you in the lecture video. I'm looking first at each denominator. And yes, I am purposely putting them in parentheses so my brain keeps these attached. I don't want my brain looking at the m and the 3 apart from each other, or the m and the 2 apart from each other, because they're not. They're glued together, never to be pulled apart. So I need this parenthesis to match up with this parenthesis. Hey, what's this parenthesis missing to look like this one? It's missing the entire parenthesis of m plus 2. Remember, you can't pull these apart. They're super glued together. And you don't have a good enough solvent to break addition and subtraction apart when they're written in a polynomial like this. What's this denominator missing to look like this one? It's missing the entire parenthesis of m minus 3. So in this particular case, the common denominator is made up of m minus 3 times m plus 2. So, to denominator number 1, I am going to have to multiply by m plus 2. But you know as well as I do, if you do it to the denominator, excellent, you do it to the numerator. Okay, denominator number 2 needs to get multiplied by m minus 3. And if you do it to the denominator, you do it to the numerator. Okay. So let's look at the numerator, the first numerator. It is m plus 2 in quantity times the quantity of m plus 4. I'm hoping that you remember how to distribute, just in case the first term gets multiplied to everything in second parenthesis. So we'll have m squared plus 4m. And then the second term in the first parenthesis gets distributed to everything in the second parenthesis. So 2m plus 8. Good? Excellent. You're like, yeah, I remember this. You know what? That's a big plus, because the more you remember, the easier the problem becomes, and you just need a little tweaking here and there. So, the first fraction looks like m squared plus 6m plus 8 all over the common denominator. And no, I'm not multiplying the common denominator. I'm not multiplying those two parentheses together. Fraction number 2. The numerator. We have another distribution problem. We have m plus 10, the quantity, that means parentheses, times the quantity of m minus 3. Same scenario, first term in the first parenthesis gets distributed to both terms in the second parenthesis. Good. And we do the same with term number 2 in the first parenthesis. It will get distributed to both terms in the second parenthesis. And when I collect my like terms, hopefully you and I agree that this is what we get when we distribute. Yes? Yay! As I said, victory. We'll take the little victories. It's always a good idea to take the little victories. Okay, so here's what fraction number 2 is looking like on the other side of the equal to sign. Now, here's the deal. Getting the common denominator helped me to figure out what the numerators really looked like. What were they supposed to really be? Because when the denominators aren't the same, I don't know if these are my actual numerators or not. Now I know these are the actual numerators I'm supposed to be dealing with. Not those, these. And so now that I've got the common denominator, which changed the numerators accordingly, the denominators have done their job. I don't need them anymore. They're just kind of mucking up the problem a little bit. So let's get rid of them. If I multiply both sides by the common denominator, then it cancels those denominators, which leaves me with something very nice and simple to work with. Just like in the lecture video example. Yes? Yes, that is much nicer to work with. Now I know exactly what I have to do. It's cleaner. I can see it. And if you remember, in that lecture video on this, refreshing of these types of problems, we have to notice, or we notice that there's a square here, a variable squared, which means we probably have to factor it or use the quadratic formula on it. But first I've got to get those squares on the same side. And when I get the m squares on the same side, hey, let's put them on the left, I'm noticing that I have to subtract it over, and it cancels. So because it cancels out, I am left with an even nicer equation to deal with. Woohoo! We can handle this. This is a piece of cake for us. So get the m's on the same side. I'm going to subtract 6m from both sides. So I'm going to get 8 equals m minus 30. Agreed? And then I'm going to move the 30 to the left by adding. So I'll get 38 equals m. Wow, really nice problem once we got the common denominators and started collecting like terms, right? Okay, one last thing we have got to check. We have got to make certain that our answer does not make either of the original denominators equal to 0 when we plug them in. Because if it does, it blows the fraction up and we can't use it. So if you plug 38 into the first one, yeah, not a 0. Plug it into the second denominator, yeah, don't get a 0. This answer then is good to go. Cool? Okay, stay tuned. I got example number 2 coming your way. Okay, I'm back with example number 2. And if you're like, hey, I got this one, great. Fast forward to number 3. Good? Okay, so we have an equation dealing with fractions. Remember what I've mentioned? We need to find a common denominator, and I always put LCD because we always want the lowest common denominator. So one of our denominators is x plus 3. Another one is, well, you know what? Let me write it this way. Hold that thought. Another one is x minus 3. And then another one is x squared minus 9. Now, I don't know about you, but that square tells me that this denominator could probably factor. And you may or may not remember, but if it is a difference of squares, and so when you factor it, and if you need help factoring, go find my refresher video on factoring. This actually factors out to x minus 3 times x plus 3. So that is the third denominator, x plus 3 times x minus 3. Now, I need this first denominator, the second denominator, and this third denominator to all look the same. So my question is, the first denominator of x plus 3, what's it missing to look like the other two? Yeah, it's missing the parenthesis of x minus 3. Denominator number 2, what is it missing to look like the other two? Again, it is missing the parenthesis, but in this case of x plus 3. And denominator number 3, hey, it's good. It's got both of these parentheses in it. Does that make sense? Lining it up in this fashion going down might be easier for some of you to actually see what's missing. So something to consider. Okay, so you are telling me that the first denominator of x plus 3 needs to get multiplied by x minus 3. Just the denominator? Good. Numerator also. Second denominator of x minus 3, you said it was missing x plus 3, so I need to multiply the denominator by x plus 3. Just the denominator? Good. Numerator also. And number 2, remember, this is what fraction number 3, this is what fraction number 3, its denominator factored to. We didn't multiply by anything, did we? So this one stays the same. Good? Okay. Let's see what this looks like. Gratefully, 1 times anything is just itself. So I have x minus 3 over the common denominator plus fraction number 2. Yeah, there's a 1 up there, so gratefully it's just x plus 3 over the common denominator equals this third fraction, and I'm going to write the denominator in factored form just so it looks like the other two. It already matched up when we factored it, so okay. So, did the denominators do their job? Did they appropriately and legitimately change the numerators as needed? Yeah, they did. So the question is, do I need the denominators anymore? No, I actually don't. So, yeah, I agree. Multiply both sides by the common denominator. So when I do that, this side is going to get multiplied by x minus 3 times x plus 3. This side is going to get multiplied by x minus 3 times x plus 3. And yes, I'm going to put them over 1 to make them fractions also. So remember on the left, you are taking this polynomial and multiplying it by the first fraction. So it distributes and it cancels. But you're also taking it and multiplying it to the second one, so that denominator also cancels. Good? Same thing over here. These denominators are going to cancel straight away. There's only one fraction on that side for me to deal with. I don't have a distribution to do like I did on the left. So what remains? Good. X minus 3 plus x plus 3. Oh, by the way, did I need that parenthesis? No. I'm just so used to writing parentheses that sometimes I forget we don't need it. By the way, why don't we need it? Some of you are not certain because it's following a plus sign. And plus signs don't change anything on us. Wow. We got a super easy equation to solve. There's not even an x squared in there. So all I have to do is collect like terms, don't I, and get the variable by itself, yes? Okay, so we end up with 2x, 0, minus 3 plus 3, 0, equals negative 5. And now, divide both sides by 2, and unless they ask for it, you don't give them a decimal or a mixed number. You leave it as negative 5 halves. Cool? Okay, so question, are we done? Yeah, good, we're not. We have to see if this answer is going to make any of the original denominators equal to 0. Because if it does, it blows up the fractions and we can't use them. So x plus 3 was the first denominator. Yeah, that's not going to equal 0 when we plug it in. X minus 3 was the second. Yeah, that's not going to make it equal 0. And the third denominator, if I plug it in here, it makes it a little easier to see. Yeah, that's not going to work either, right? So this answer is good to go. Cool? Okay, stay tuned. Example number 3 coming your way. Okay, let's look at example number 3. And again, if you say you've got this, fast forward to number 4. Okay, so we're dealing with an equation. It has fractions. First things first, find common denominator. Okay, so the first denominator is x minus 2. The second denominator is a 1. And even though it's a 1, write it in there. Third denominator is x squared minus 5x plus 6. Okay, so just like the last problem, That square tells me that this is more than likely going to factor. So, did you factor it yet? No? Factor it. I'll wait. Okay. Hopefully we get the same thing. And if you're like, I need help factoring, okay, go look at my lecture video on factoring, the refresher videos on factoring, and that will help you with getting these common denominators. All right, so let's look. Remember, I need all three of these, because this is what I'm looking at now, to be the same. I need them to look exactly the same. So x minus 2, what is it missing to look like these? Well, it's definitely missing x minus 3. And yeah, technically you could say it's missing the 1, but 1 times anything is just, anything. It's just itself again. Number 2, it is missing both sets of parentheses. Whoops, one of those was supposed to be a 2, right? There we go. And the third one, well, technically it's missing the 1, but again, 1 times anything is just itself again. Okay, so ready? Denominator number 1, it was missing x minus 3. So I'm going to multiply top and bottom by x minus 3. Denominator number 2 was missing both of them. So I have to multiply both the numerator and the denominator by x minus 2 times x minus 3. And denominator number 3 wasn't missing a thing, so I don't have to worry about that. Good? Okay, let's see what we got. So the first numerator is going to be 2x times x minus 3 all over x minus 3 times x minus 2, the quantities, right? Okay. Minus, gotta be careful. 1 times x minus 2 times x minus 3 all over the quantities of x minus 2 times x minus 3 equals, and number 3 fraction, denominator didn't change, but I'm going to write it in factored form just so it looks like the rest of them. Good? Okay, so what's our next step? Good, just like we did in the previous 2 problems and what I did in the refresher video, we're going to multiply both sides by the common denominator because we don't need it anymore. All it did was help us to see what the real numerators were that we had to deal with. So, are you okay if I don't write that step? Good, thank you, appreciate it. So let's look. This means we have 2x times x minus 3 minus the quantity of x minus 2 times x minus 3 equals 8x minus 24. Looks like we have some multiplying to do. Distribution. 2x squared minus 6x. Good with that? Okay. Now we've got a subtraction sign, so I'm going to be careful here because you know as well as I do, a subtraction sign changes things. So, I'm going to keep this distribution in parentheses. And I already know what this distributes to because we did it up here, we broke it down. So it's x squared minus 5x plus 6 equals, so far so good? Okay. Now, we still have a set of parentheses to get rid of, which means this minus sign has got to go. So remember, you're basically distributing a minus 1 into that parenthesis, and if you need to write the 1, then write it. So we end up with 2x squared minus 6x minus x squared, good, plus 5x minus 6. Excellent. Good job, you guys. See, this is why you needed to do it before me. Make sure I stay on track. Okay. On the left side of the equal to sign, there's a lot going on. So let's simplify it. Let's collect like terms. What are we collecting? Good, 2x squared minus 1x squared. Well, that'll just be 1x squared. And negative 6x plus 5x. Good. Gives me a negative x or minus x. Oop. And we took care of this and this and this and this, and we also have plus 6 over there. Must remember that. Because if I don't remember it, we're going to get the wrong answer. How are we doing? So far, so good? Okay, now what? Yeah, the x squared tells me I'm either going to have to factor or use the quadratic formula, which means you've got to make it equal to 0, right? Which means you got to move everything over, yes? Okay. There's no x squared to move over, so you know that x squared is staying. I'm going to move the 8x over by doing what? Good, subtracting. So I have minus x minus 8x. Good. Minus 9x. And then, good, I have positive 6 and I am adding 24, aren't I? So that gives me a positive 30. How are we doing? So far, so good? Excellent, loving it. Okay, so how about if we see if this thing will factor? Because that'll be really nice if it does, won't it? Okay, so if you do 1 times 30, this is my quick showing you, 1 times 30 will give you just 30, positive 30. So all the combinations for 30, what, we've got 1 times 30, both positive or both negative. We've got 2 times 15, both positive, both negative. 3. 3 times 10, both positive, both negative. 4, nope, 5. 5 times 6, both positive, both negative. All right. Let's see. Do any of these combinations, when I add them together, will any of them equal 9? No. Well, that's a bummer. Hey guys, I paused the video a second because I noticed I did something wrong. Right here, when I collected the x squareds, I got 1x squared. When I collected the minus 6x and the positive 5x, I got a negative x. But this was supposed to say a minus 6. And I, for some reason, put a plus 6. So it should have stayed a minus 6. And then, when I brought the 24 over, so you have a negative 6 plus 24, which gives you a positive 18, equaling 0. Are you with me? Which means my side work over here needs to go bye-bye because I'm looking at the wrong combination. Okay, so now we're factoring x squared minus 9x plus 18 equaling 0. If you need to look at my lecture video, go look at my lecture video. But I already know this is going to factor to the quantities of x minus 6 times x minus 3 equaling 0. And then I set each parenthesis equal to 0. And I solve. So I have x equals 6 and x equals 3. Good? Good. Okay, are we done? Nope. We need to see if x equals 3 and x equals 6 and x equals 3 work for us. So let's go check to the original denominators. 6. If I plug a 6 in to the x minus 2, we're good. Doesn't equal 0. If I plug a 6 in here, and this is what it looks like factored, it might be easier to see. Yeah, it doesn't make either one of these 0, so we're good to go. 3. If I plug a 3 in here, we're good. If I plug a 3 in here, let me go take a look. This is easier to see. Well, this will be a 1, but this will be 0, won't it? If I plug a 3 into this denominator, it'll make it equal 0, which means it'll blow it up, so to speak, which means this answer doesn't work for us. So the only solution, even though we got 2, the only one that works for us is 6. You only have one solution for this problem. Good? Cool. Thanks for letting me correct my mistake. I am human. So we have one more example. Stay tuned. Okay, here's the last of those 4 examples. And if you've gotten this one, then obviously you can fast forward to the end and voila. But for those of you who are like, yeah, I need help with this one, let's go through it. You know what we have to do as well as I do. Common denominator. Let's look at the first fraction. 5 minus x. Ooh, okay, so I'm going to stop right there. First things first, it's not in descending order. So get it in descending order. So this would be negative x plus 5, right? Okay. Second thing I'm noticing is my lead term is a negative, which tells me I can factor out. The only thing I can factor out that's in common would be a negative 1, which means you would get x minus 5. This type of denominator you have to be very careful of. If it's not in descending order, put it in descending order. And if your lead term turns out to be negative, you must factor out that negative 1. Got it? That's the one that will always try to trick you. So be very cautious about it. Cool? Okay. Denominator number 2, x squared minus 2x minus 15. Okay, I'm noticing x squared, which means it's going to factor, and I already know it's going to factor 2x plus 3 times x minus 5. So please, again, go watch the lecture video and refresh your brain on how to factor if you need to. And the third denominator is x plus 3, and I have nothing to do with it because it's in descending order and the lead term is positive. We're good. Okay, so I've got this denominator, and this denominator. And yes, I put a little circle by them so I know which format I'm looking at. Okay, first denominator. What's it missing to look like the second one and the third one? Yeah, it's missing the x plus 3. Second denominator. What's it missing to look like the first one and the... Yeah, this one is missing that minus 1. Ooh, that's important. It doesn't matter if it's missing a positive 1 like the previous example, because multiplying by a positive doesn't do anything. But when you multiply by a negative, you know as well as I do, it changes a whole lot, right? Okay. And denominator number 3. Yeah, it needs the x minus 5, and it needs the negative 1, doesn't it? Okay. Let's get back over here. Remember, this is this denominator. And we said it was missing x plus 3. So to the denominator and the numerator. Right? Okay. Denominator number 2, we said it was missing this negative 1, this minus 1. So you're going to multiply by a negative 1, top and bottom. Got it? Denominator number 3 was missing the x minus 5 and the negative 1. So to the top and bottom, we are going to multiply by such. Cool? All right, let's see what's going on. First numerator, 3 times the parentheses or the quantity, x plus 3, all over, and I'm going to write the common denominator in this format because that's how we wrote them over there. Minus. Ooh, I have a negative 11 up top, don't I? Can you see what's going to happen? Good, so can I. But we'll leave it alone for now. Don't do 2 steps in one, please. That's a sure way to get us all kafluid. And we have, if you're okay, I'll do negative 1 times 4. It gives me that negative 4 times the parenthesis of x minus 5. Okay. All the denominators are the same. And in this case, every numerator got changed appropriately, right? Okay. So did the denominators do their job? Yes. Should I keep them, or should I multiply both sides by the common denominator to get rid of it? Good. I like option B too. So if you're okay with it, just for the sake of my board space, I'm not going to write that I'm multiplying this putting this side in parentheses and multiplying by the common denominator, and the same on this side. We're going to assume that you can visualize that I've done that, and our result will be 3 times the parentheses of x plus 3 minus a negative 11, right, equals negative 4 times the parentheses of x minus 5. Cool? That doesn't look too bad, does it? Okay, what'd you get for the next line? Talk to me. I hear you. You said 3x plus 9. Plus 11. See about that negative sign? Tried to trick us. Good. Negative 4x plus 20. Excellent. Excellent. Okay, so, all right, you guys want to collect like terms on this side. I heard you. So that'll be plus 20, right? Now what? Move all the x's to one side. Which side do you want to move them to? The left? So it means I have to add 4x. Okay, so that becomes 7x. Good. Now what? Yeah, this 20 that's on the left, you got to move to the right by subtraction. Oh, and that's interesting. Let me write this, because us visual people might want to see what's going to happen there. Our brains are interesting. So what do you get? 7x equals 0. Some people, some of our brains, we don't like the fact we got a 0. But so be it. If we got 0, then we get 0, and that's okay. Don't try to trick it into making it like 40. 0. We're good with it. And again, some of us should literally do this step of division by 7, so we see that x equals 0. So, hey, I like 0 as an answer. But the question is, are we done? You're right, we're not. We have to make sure that when we plug in 0 to the original denominators, that we don't get a 0 in the denominator. So, 5 minus 0, yeah, that's not 0, we're good. If I plug a 0 into this one, yeah, we end up with negative 15. We're good there too. And here, we end up with 3. This one's good to go also. Just because you got 0 for an answer doesn't mean it's incorrect or it's not going to work. It's a viable number, so make sure you're good with it. Okay, hopefully you had fun with these 4 examples. Hopefully they made sense. Go back and review them as needed. Have fun. Catch you on the flip side.